Hello everybody and welcome to my live stream. It's good to be back. We're back this week. We're doing something a little bit different this week. So we've been doing a lot of gaming and Unity stuff, and we're going to kind of switch back. Not a lot of people were really into the gaming and Unity stuff as much as I thought they would be, and I had a few requests to jump back into doing some like Python and things like that and some Golang. So I've decided a good way to do that is to do a little bit of computer vision. So today we're going to do some computer vision stuff with OpenCV. Now, computer vision is basically making computers see things the way humans see things. And so I thought it would be kind of cool to do a very introductory kind of lesson, if you will, on doing some stuff with OpenCV. All of the stuff you can do at home. You can do it with a few lines of code, and I'm going to show you how to manipulate images, how to read images, open them, how to look at them, things like that. And so without further ado, I'll jump right in. See, there's my screen here. We've got Visual Studio Code up. I'm going to do a quick tech check to make sure I am streaming where I should be streaming, and it looks like I am here. And today I'm going to all of the destinations, but generally I just stream on Twitch. But today I've decided to do quite a bit more. So let me mute some of these here, so I don't hear a bunch of echo, right? And we'll jump right into this. Oh. One thing I probably should do is load up the chat screen, right? I will take your questions in chat, questions and suggestions, all of that kind of good stuff. But let's jump right in and get started. We're going to do some stuff with OpenCV. It's going to be fun. It's going to be cool. So the first thing we'll do is we will create create an environment first. So I'm going to be doing all my terminal stuff down here. We're going to say Python -m -v. I can never type when people are looking. We'll just call this OpenCV demo, which is what I've called the project. Cool. Source, OpenCV demo, bin, activate. All right, now we have our Python virtual environment created. I always recommend that to people when you're doing Python stuff. Use the virtual environment. It's kind of a cool way. It's almost like a container type thing for your project so that you can keep all the dependencies together. You can kind of ship, in a way you can ship your Python out and you can have other people build that exact same environment that you built it with. And we have our first spammer on the channel. No, thank you. I'm good. Where's my moderation tools when I need them? Deleting that. You're out. All right, so we have OpenCV demo here. Let's do, see, one of the first things we could do is we'll load up an image. So first we need to make an image. Right, so we'll go here. We're going to go to DALL-E, and we will just create an image. I don't know if I'm signed in here, but humbug. We'll go to another one here. There it is. We'll go to DALL-E. We're just going to generate some silly image on here. And I did this recently. Pretty cool stuff. So we're going to do something like monkey riding a skateboard. And we'll just do like one of these AI generated images. And then that's what we'll open up and work with. Actually, this dog sitting on a hamburger is probably more fun than monkey riding a skateboard, but you know, whatever. And by the way, I'm doing this with Python. And I probably, instead of a monkey riding a skateboard, I should have done something like pixelated art or something to make it more complicated. But doing this with Python 3.10, I believe. I never know on this machine. Yeah, 3.10.9. So you can do this at home. We're going to use the OpenCV library. And you really don't need a whole lot other than the code that I'm going to show you today. I'm going to put that up on GitHub also. Everything we build today I'll put on GitHub. And I'm going to write an article on jeremymorgan.com as well to kind of help you out with that, with all of the cool stuff that we're doing today. And Dolly is taking a little while. There we go. We have monkey riding a skateboard. See, that actually looks terrible. So I'm going to take, here's a guy on a skateboard. I think this is better. This is some stuff I was experimenting with last night. Let's go into our projects. OpenCV demo. In here, we're just going to make this our image.png. Save. Cool. We've got that. Now we're good to go. So the first thing I want to do with this, we need to import CV2. So the first thing we'll do is we'll just make this one called showimage.py. Bring this down. CV2. Pip install OpenCV. Oh, and I need to upgrade pip. What a surprise. I forgot it's OpenCV-Python, not just OpenCV. Let's upgrade pip. Why not? Just in case we need to install some other stuff. Okay, so now we've got OpenCV in here. So import CV2 should work. And just a second here. I'm going to make my notes a little bit bigger so that I can read them. And I've just got a set of notes to kind of guide me along so I don't forget anything that I want to cover today. So we're going to load up an image, and the way we do that is we'll say image equals cv2.imread, and then the name of the image, which in our case is our image.png. Save it. Python showimage.py. Our image can't be read. I haven't seen that one before. Why won't import CV2 work? That's a great question. Could not be resolved. The very first demo I try to do and it doesn't work. Check file path integrity. Our image. Oh, I spelled it wrong. Good job, Jeremy. Doing great. Okay, so there we go. So now we're reading the image in there. We get no error message. We're all good. So we want to show it, right? So the first thing we'll do is CV2 IamShow. And we'll name this. We give it a key. Image. Now, there's one thing that I'm going to show you that you're going to run into pretty much all the time. People run into this the first time they go to use OpenCV. And that's because every tutorial in the world tells you to do it a certain way, and that way it's pretty wrong. It's only wrong sort of. And I will show you exactly what I mean here. More spam, jeez. So in all the tutorials in the world, it says CV2, wait key, 0, and then it will do the CV2 destroy all windows. And this is how it tells you to do it, and it's fine, it's not wrong. However, here's what you'll notice. Whoops, wait key needs, the key needs to be capitalized. Okay, so it's showing us the image. This is cool, this is awesome. And because of the way this code's written, it's just gonna wait for me to close it. That's it. Just quit or close, whatever. What happens a lot of times is you'll have this thing open, close it, and I know it's kind of hard to see on the stream, but down here in my terminal, Python show image is hung open after closing that window. So if you don't press Q, it will close that window, which sucks because then you gotta, you can't control C out of it. You just basically have to create a new terminal. PS, AUX, let's find it. Python show image, that's number 277. So we'll do kill-9, 277, what was that? 27716. And kill that process. So what you can do when you're doing this, say Python, what was it, show image py. We've got this open. What you can do is press Q to quit, which really isn't documented. You can press Q to quit and it'll go back, or you can add like 3 seconds to this. So if you do wait key 3000, that's 3 seconds. 1 alligator, 2 alligator, there it goes. That's another way you can do it so that you won't get these hanging Python instances. It's kind of annoying. It is what it is, but yeah, it's just a little trick. So a lot of times that's what I do is I'll just put this thing for like 5 seconds just so I can open it up, get a look at it, be like, yeah, that looks the way I want it to look. And then be like, okay, cool. So now we know how to read an image and show an image. That's not really super important, right? What we can do is we can write an image before we show it. And let's see, I'm going to start putting in some comments in here. Open the image. Show the image. Wait for a key. Close everything down. And we can put wait for the Q key. So what was one of the other things I'm going to do here? If I can find it. Okay. Just looking at some messages here. So we could do some different things with this image. And so in my notes, I've got just kind of a list here of do this, do this, do this. The next one is blur the image. So we can blur the image using a Gaussian blur. And I'll show you how we'll do that. Image blur equals cv2 dot Gaussian. Get his Gaussian blur. Blur. And then we pass in that image. 5,0. This is a Gaussian blur here. And so what this does is this 5,5 is the kernel size. And what it means by the kernel size is it takes a matrix of pixels. So if you select a pixel on the image, 5 pixels around it, it will average those out. And that's how it comes up with this blur. So basically you're saying 5 by 5, we want to use a 5 by 5 kernel size so that every pixel will be the average of the 5 by 5 around it. Blah, blah, blah. Now let's see what this looks like with a pixel blur. Ah, it has no Gaussian blur. That's horse. Puggy. I just probably spelled it wrong. There we go. And so now our image is just a little bit blurrier, right? It's softened, if anything. And that's all it does, is it kind of averages out all the pixels around the pixel, and it kind of averages it over and softens it out. Let's take a look at both of those. Here, let's show the original image here, and then we'll put blurred image, and let's look at both of them. There you can see a difference between the sharpened image and the blurred image. We'll do the weight key here. So yeah, here we're looking at two different images. Over here you can see on the left, you can see it's really sharp. It almost looks like writing over here. Over here it's blurred, and you can kind of change, you can change this matrix a little bit. This is a tuple right here, tuple, whatever you want to call it. Oh, and I froze it up. I didn't press Q again. See, that thing I warned you about is something that I do myself quite a bit. So we will kill that other show image, which is 28,710. Cool. And now we're back with a new terminal. So we changed this to 4 and 4. Let's see if this works. I've noticed when you change these, since I don't really understand exactly how they're set up, to change that kernel size, sometimes it screws up, but we're going to try it. Yeah, see, this one's like assertion failed. It won't let you do many different kernel sizes. And I'm not sure exactly why. We can do 5, 5. There we go. And we'll quit. And so that's how you blur an image, right? Pretty exciting stuff. What's kind of cool about this is this OpenCV pretty much runs self-contained to do a lot of these things. So you could build a web app. And actually, I think I might do that on one of my streams. Maybe we'll take some of this stuff and put it into a Flask app so that you could do a web app with this stuff where people can upload their image, blur it, have it come back, something like that. Be pretty cool. And we can also write these images. So let's do CV2, IM write. A lot of stuff is IM, like, and I believe it's image management or something. I'm not exactly sure. We'll call this result PNG, and we will write the blurred image. So we'll say image blur. We'll do this one, Python show image. We look at it. Yep, that's a little more blurry. That's what I want. Quit. Now we have result PNG. So we have our image and result PNG. Pretty cool, right? So what if we want to do something like grayscale, like pull all the colors out of this image? That actually turns out to be really easy. What we can do here is, so we got the Gaussian blur part. Let's just create another one. Create another Python script called Grayscale, PY. Copy this stuff, pull it in. We still want to read the image. We don't want to do the Gaussian blur. We do want to do a show and a write. and the weight key, so we'll keep all of these in. Now for this one, we can say gray equals CV2 dot CVT color. We want to take in that image. We pass this into the CVT color method. We pass in this image and we say CV2 CVT color. No, is it CV? No, it's color. And then you can change a bunch of these. So we'll do RGB to gray. Pass this image. So in this one, we'll show the image, then we'll say gray image. We'll pass gray into there. We'll write our result as gray. We probably won't write results for all of these. Just kind of a heads up. It's not really that important right now. Just kind of wanted to show that we're able to do that. So this didn't work. Do gray image, gray, CVT color. Maybe this is not an RGBT. Maybe this is a BGR to gray. Nope. So gray. I'm going to comment out. All right, and our result is not gray either. So we did CVT, color, image, CVT to color, BGR to gray. Very interesting because that should work. And I'm not sure exactly why it's not working. So we could do CVT, let's see, I am read. Read it as grayscale. Nope, that's what I thought, just reading. So that one, I'm not sure why that's not working. Let me look that up here. I've done the grayscale one several times. Usually it works pretty well. Oh, and another thing I noticed, my tab 9 isn't working. Interesting. You get used to it after a while. Like the autocomplete from this thing is just awesome. So bear with me for a minute while I sign in here and load up tab 9. Okay, there we go. Logged into Pro. So if you have any questions or anything, feel free to throw it in the chat. Now I've got tab 9 going. That helps a little bit. A little bit with the auto completion. Congrats on your first tab 9 code completion. I'm going to see what tab 9 suggests for this. CV2 equalize hist. Not quite. I'm going to check something else. Very interesting. This is the way I've always done it, and this is the first time I've seen it not work. Look at this. In fact, I'll copy this from this website, and we can see it's almost identical. This is the one we were using that BGR to gray earlier. So yeah, this should work, and I don't know why it doesn't. This absolutely should be grayscaled by now. Gray image. Yeah, I have no idea why that's not working. It is incredibly odd. So we're reading in IM image, passing it in, changing it to color BGR to gray, and it is not showing it as gray. What happens if I show the image? The image is the image. But gray, by golly, should be gray. All right, well, that demo failed. Maybe we'll come back to it. I've never seen that particular thing fail like that. Like, it fails quietly and it doesn't do what it's supposed to do. I have no idea. No idea. So we'll just have to skip hold. Now, thresholding is what we'll do next. Thresholding is really cool. It's like separating a picture into what you want to keep and what you want to throw away. So basically, with thresholding, you can say, I want to keep all the bright colors and toss all of the dark colors. Or I want to keep all of the dark colors, toss the lighter colors. It gives this cool kind of artistic effect. Hello, Noob Gaming Dad. Thank you for joining the chat. Your question, why the title still say blurred image when it showed? That's a great question. I think you just actually found my problem. And I feel really smart right now. I've been running the wrong script. I was running show image Python, which is a mistake that only I could do on stream, right? So thank you very much for that help. If I do Python grayscale.py, there's our grayscale image. So thank you very much, Noob Gaming Dad. I didn't even realize that because, yeah, I have streaming brain, right? I'm like not thinking about it, but I was sitting there running that old show image over and over. That's why I was kind of confused because I just never seen it silently fail like that. Well, it wasn't silently failing. It wasn't failing at all. I was running the wrong Python script. So that's what our grayscale image looks like if you want to do grayscale. We're going to do a lot of artsy fartsy kind of stuff here for a little bit, and then we're going to do some face detecting if I have the time. I'm hoping I have the time to do some face detecting. That would be really cool. But yeah, here's my thing. Oops, text. All right. So thank you very much, Noob Gaming Dad, for that. That is pretty cool. So we can grayscale the image. As long as I run the right Python script, we have grayscale. What was I saying? Oh, the next thing I wanted to do, according to my notes, is thresholding. Thresholding is kind of a cool art type thing, mostly is what I've seen it used for. I'm sure there's tons of actually legitimate uses out there for thresholding. I just haven't used it yet too much, so I'm going to say thresholding py. We're going to copy in all of our image read stuff. We're not going to do the grayscale anymore. Let's see. I'm just going to kind of use this as my skeleton, if you will, for stuff here. All right, so for thresholding, you actually read it in as grayscale before you start. So in order for thresholding to work, it does have to be grayscale. But it's read in as grayscale instead of turned into grayscale, if that makes sense. So what we do here is read in our image, and we throw an extra parameter on here, CV2, dot. There we go. And we can IM read color, decode. In this case, we're just going to say IM read grayscale. And so we're reading this in as grayscale. This time I will change this to thresholding .py. All right, so we're reading it in as grayscale. So when we show that this one is grayscale. And then we need to apply the thresholding. So first thing we come up with is our threshold value. 100, probably 128. Max value 255, and you can see basically in here in the thresholding, or I mean in the tab 9 auto completion, you can tell that somebody's done thresholding before because yeah, it's throwing in these comments that are pretty relevant. Look at that. It's actually probably threshold image, CV2.threshold. That's right. Passing in the image. That's right. It's passing in the threshold value, passing in the max value. Thresh binary. That's pretty amazing. So basically tab 9 knew through their auto completion knew exactly what I was going to do here. It saw me create this threshold value and this max value, and then I started to do this, and it's like, oh, you're thresholding an image with OpenCV. So that's pretty cool. So what this does here is we pass this into CVT threshold, pass in the image, how much, like the threshold value, the color we want, and then the max value, which is 255, which is black, basically 255 all the way across is black. And let's see what this looks like. Oh, and I have to create another terminal. Python kill -9 32877. All right. Python thresholding.py. Okay, that doesn't look very thresholded. Oh, yeah, because I did not put in the threshold image. If you've never seen this before, you're probably like, what the heck is threshold? Why does it keep talking about threshold? But as soon as you see it, you'll know. It's one of those, right? So like I said, pretty artsy. So basically what this has done is it's taken all of these edges and it's taken the lighter colors, turned them just bright white. It's took the darker colors, turned them black. And so what it does is it makes this kind of artsy look. And this isn't really just for generating art, by the way. This is for computer vision as part of the preparation. Sometimes there are certain images that when you're reading them and you're doing evaluation, this makes it a lot easier to do that evaluation. So thresholding is basically something that you do in prep before you load it into an image model. It also creates artsy looking images that are kind of cool. So it's a little bit of its usefulness, but it also looks kind of cool. So that's image thresholding. And you'll notice when you start to go through computer vision courses and tutorials and things like that, they will tell you to do certain things. They'll be like, use erosion on the images before you load them in, use thresholding, things like that. So that's one of the reasons I'm showing you this, is not only to show you like how easy it is to do these things. You know, say if you want to do an art thing, there's a lot of artistic things you can do with these and generate an image and send it out. But this is also a cool way to prep things, and it makes it really easy. I mean, this is just this one line of code right here does that thresholding. So when you're going through a course or a tutorial or reading an article and it says threshold the images, crop them up, etc., you can say, oh, I know how to do that. It's right here. So that's thresholding. What's the next thing we want to do here? Copy and paste. We're going to do some erosion, which is another thing you will see in your lessons and tutorials. So we're going to pull out all the thresholding stuff. Instead of threshold image, we're going to be erosion image. So we'll change those two. Remind me to change that script that I run. Thank you everybody for watching. Thanks Noob Gaming Dad for the question that led to our answer. But thanks everybody for watching here. Today I'm streaming to several different platforms. However, oh, and I just noticed that's interesting. Chat doesn't appear to be coming up, but that's fine on some of them. But I'm streaming to a bunch of different platforms, but primarily I stream on Twitch. Twitch is where I love to be. Twitch is awesome. So if you're watching on one of the other platforms, I'm usually not there, but I'm always on Twitch. So I'm not always on like Facebook and LinkedIn and stuff like that. But I'm always on Twitch. I do this every week. And for the next few weeks, going to be doing a bunch of Python stuff, a bunch of computer vision, machine learning, fun stuff like that. I actually got a message from a fan who watches my streams for quite a while. It said, let me know when you're done doing the Unity stuff. and then I got a couple of other messages like, hey, when are you going to start doing other stuff again? So traditionally my stream has been, Golang, Python, C#, that sort of thing. I got into the Unity thing, had a lot of fun. I really liked it, but the people watching weren't really that into it. So we're going back to this for a little bit. I will return to the Unity thing at some point, but that, and I'm doing a JavaScript game for my day job. I like to call it my job. Every time I call it my job, it seems silly, but for the day job, I'm doing some JavaScript gaming. So it was a little confusing to learn JavaScript gaming and Unity at the same time. Noob Gaming Dad says, as a C# dev, do you know if it is easy to do this on .NET? It absolutely is. So there is an OpenCV library for .NET. Well, there's a hard way to do it and an easy way to do it. So the hard way to do it is probably to use IronPython. And with IronPython, you can write Python and .NET. It's amazing. It's awesome. I mean, obviously, I love both of those things. I love .NET and I love Python. However, I don't do a lot of IronPython. And it's not because it's bad or anything, but I kind of just fail to see the point when you could just write Python and put it somewhere. I haven't needed a lot of the .NET things that come with that, but you can do it with IronPython and do this, or you can do OpenCV 2 directly with .NET. I'll see if I can find the library that I used previously. You can also do like computer vision with Azure and stuff. They have a bunch of sweet tools, but it is nice to not have to pay for it every time you use it, right? I believe I wrote some, oh, there it is. I will post this link. EMGUCV is the .NET wrapper for the OpenCV library. And I was trying to find the GitHub for it. but I'll paste the link. EMGU, GitHub. Ah, there it is. Okay, I'll post the GitHub. And I wrote a couple articles on allhandsontech.com for work. The link. OpenCV wrapper. There we go. I've used this library. It works great. It's almost exactly the same. So I've done a bunch of computer vision stuff with OpenCV and Python over the years. I've done a lot of this. And when I jumped into the C# part of it and started doing it, I thought, well, this is probably going to be a pain in the butt. It's not really. I mean, you could almost, the code is very similar to what I'm writing here today, but in C#. It's fun. If your idea of fun is the same as mine, it's very fun. Okay, so what were we doing? Oh yeah, we're going to do erosion. That's right. So erosion is basically, so it's taking away smaller parts to make things more simple, right? So I guess like erosion in real life. You know, water goes running down and takes all the sharp edges off the rocks after thousands of years, right? So it's simplifying. That's basically what erosion does with JPEG images, is it takes a kernel of images, like before, the 5x5 kernel, averages them out and brings the colors together. And basically what it does is it roads down sharp edges, dots, and makes them kind of smoother. So this is also an artistic thing. It kind of ends up artistic when it comes out. And it's also useful in computer vision stuff. So we're going to read this one in Grayscale the same way as before. We need to import NumPy for this one, though. Oh, look at that. It already knew I was going to do NumPy. Oh, already satisfied. Cool. So our erosion image, in this one, we're going to say, oh, we need to create a structuring element. So we need to create that kernel that I just talked about. Almost forgot about that. Kernel. Oh, look at that. 5.5. That is interesting. There we go. So, kernel for structuring element. And again, this is taking a 5x5 kernel. It's a 5x5 section of that, that image around each pixel. Check some cat. So, we're just saying 5x5 NPUN8. We've got that kernel. Now we need to apply the erosion. So apply erosion. This is erosion and dilation, which is probably true. So we'll put that in there. Erosion image equals, is it going to put in? Yeah. Okay. So once again, tab 9 is your friend, and it puts it in there, but let's explain. So it does a CV2.erode. In this method, you pass in your image, obviously, but you pass in this kernel that you created, and then you say iterations 1. So one iteration should erode that image. Let's see what it looks like. Python erosion.py. Look at that. And that's what I mean by like kind of artsy. This one, again, looks a little bit artsy, kind of looks cool. So this is an AI-generated image, obviously. So it's already a little artsy. It's already a little styly. But, yeah, works great. And that is erosion. We can do 2 iterations. Let's see what 2 iterations does. And as you can see, it erodes it down even further. I mean, who knows how far you can go with this before it just becomes a blob. Oh, and I still do this all the time. I forget to hit Q. But I will get back into that habit again so that I don't have to keep killing my processes. Now I think I've done it enough times that you will probably remember to press Q. Python, erosion PY. Now it's pretty eroded pretty bad. That looks pretty terrible. That's why I did one iteration to start with. Let's see what 100 iterations looks like. Just black. What about 50? Almost black. Blobs. So for iterations, you can use that to kind of fine-tune exactly how much you want to erode that image down. And this is iteration of 1. It kind of makes it artsy, kind of styly. It's pretty cool stuff. And that is erosion. And basically you're just removing the bright spots and bright lines. So if there's any lines that are very sharp or a bright spot that's very sharp, like think about stars, erosion is a good way to just completely get rid of stars. And it's not quite like a Gaussian blur. It's a little bit different because it does replacement of the pixels as well as blending. So it's a little bit different, but that is erosion. Dilation is the next one I have on my list. Dilating is like adding thickness to a drawing. So think about it like that. So basically making things more bold, more visible. It's very similar to erosion. Erosion kind of smooths things out. Dilating makes things bigger. So if you think of like a cartoon, so if you're drawing a cartoon, dilation will just make that line thickness bigger. So everything in that cartoon that you've drawn as a line will become bigger and thicker, and that's what we'll do next. So we will copy our code from erosion PY so you don't have to sit there and watch me type it over and over. We're going to say dilation PY. Now for dilation, we also read it in Grayscale. Same thing. You'll notice that a lot in computer vision is because it just simplifies things to load them into Grayscale, especially if you're doing analysis on it. So for this one, we read it into Grayscale and we put it out Grayscale. So we take away all those colors, and it's just better for analysis. It's easier to analyze these images. And there are several other reasons that I'm probably not aware of, but converting things to Grayscale is just something that you do a lot before you do any processing. So we're reading this in as Grayscale. We did our erosion earlier, but now we want to do dilation. So we'll say dilated image. And this might just be something that you want to do, like if you have a really large image with very small items on it. Oh, and look at that. Pretty much, yeah. So this one's doing an MP1s. It's setting up that kernel. We need to do the kernel thing again, which is pretty easy. Kernel, NP1s, 5.5, same kernel as before. I probably shouldn't even have deleted it, actually. So our dilated image is going to be cv2.dilate. And then the image, the kernel, and iterations. So it's exactly the same signature as the other method that we just used. Now let's see, Python dilation. And I don't know why I put dial in there. I spelled it incorrectly, but check that out. That's our dilated image. All of the lines are thicker. So these lines here. And one thing that I haven't been doing that I need to do is display the original image. So we're going to say dilated. I don't know why, like I put dilated in all of these, and that is not the proper spelling of that. There we go. So we're going to do the original image versus the dilated image, because I should show you the difference in those two as we do it. All right, Python, dilation, py, spelled improperly, of course. This should show us both of them. So there's our grayscaled image as it's loaded in, and there's the dilated image. And you can see that is quite a bit different, especially with the lines. That's where it's easiest to notice, is in lines. So these lines here that are pretty sharp, there's some sharp lines around the skateboard there. And you can see that they are thicker on the right-hand side. So that's what dilation does. It is the same with iterations. So if we do multiple iterations of this, you can see that things get dilated way more, like tons more. So very cool. And I gotta check this message. But yeah, that's dilated like a lot. And I'm sure if we put it to 100, it's probably just pure white. Maybe? Yeah, pretty close. We are almost pure white with 100 iterations. So that's what you do to change the dilation. So instead of changing the kernel size, which some of the, like with the Gaussian blur and things like that, you can kind of adjust the kernel size. But instead of adjusting the kernel size, you just adjust the iterations until you get it dilated right where you want. So if you have something with really thin lines, there we go. 1,000 makes it pure white. Awesome possum. That's dilating an image. And what do I have next on my notes? Image blending. Image blending is cool. So we'll save this. I'm going to close it and rename it so that it's spelled properly. Because like I said, I'm going to put this on GitHub for folks so they can just kind of jump in and use it as a reference. This is our dilated image. So we're going to do some image blending next. So I'll say blending. Put this in here, and I'm going to grab a couple pictures. I'm going to grab some pictures with faces on them because we're going to use that later. So keep these in here like this. All right. Now here we tried to do, let's see, let's go to pexels.com. Smiling person. There we go. We've got a couple of smiling people here. So we'll go into our projects, OpenCV demo, images, smile1.jpg, save. I kind of want one with an entire person in it, if possible, for one that we're doing. I don't see that, so we'll just we'll take this fella here. We'll call this Smiling 2. And let's load that up. Here we'll just do a regular read. Instead of grayscale, we're just going to load this in like this. And we're going to load one of those people. So images, smiling1.jpg. We're just going to read this in normally for now. Python blending py. Would help if I put the proper extension on it, right? Cannot read images, smile. Oh, it's smile one, not smiling one. There we go. We've got a smiling person here. Very great. One thing that's kind of cool about this image viewer, and this is something that will come in handy as you're doing computer vision stuff, is you see how I move the mouse over here, you can see the coordinates. So it shows the X and Y coordinates on the image and the RGB values. Now they are reversed when you read them in, but that's probably for next stream. Maybe we'll talk about some of the JPEG dynamics, JPEG and PNG dynamics. That's pretty cool. But you will need this reference at some point in your computer vision journey as you're building computer vision stuff. You will need these coordinates for things. Like if you'll say, I want to know exactly what this line is on her shoulder, you'll be able to say, okay, X is 80, Y is 282, all the way down to X34, 307. So it's really cool that they give you this. So that's our first image. Let's load up our second image. So we're going to call this one image 2. Say image 1, image 2. Let's show both of those. Smile 1. Uh-oh. I did mess up a little bit there, didn't I? Smile 1, smile 2. So these are two smiling images. Two smiling people. So great. One of them is clearly larger than the other one, which we can address that. But what I want to do is blend these two together. That would be ideal. They're a little bit different sizes, so it's a little weird, but what we'll do is we'll resize these so that they're the same size. Because if I try to blend them like this, it's not really going to work properly. So we'll say resize the images so they are the same size, so they match. Resize its image so they match. So we're going to do image 2 seemed to be the bigger one, right? So we're going to say image 2 resize shape, and we'll try to resize it to the shape of the other image, image 1. And autocomplete almost worked entirely for that one. So here we have cv2.resize. This method, pretty simple. You say image 2, which is the one we want to resize. He's a lot larger. We pass it into cv2 resize. We pass in the image that we want to resize, which is image 2. And that's the gentleman who's smiling. His image is quite a bit larger. And then what do we want to resize it to? Well, we can just put any arbitrary number in here, right? So you could put in 300 by 400, 500 by 600, whatever, and have it resize. It won't keep that aspect ratio if you don't look for the aspect ratio. But what we're doing is we're just saying, what is image shape 1 and image shape 0? What are the dimensions of the first image? Match it to that. So let's do that, and then we'll run this again, and they should be the same size. They might not look quite the same, but they should be about the same size. Yeah, so there is a little bit of an aspect ratio thing. I think This gentleman would appreciate it that it makes him look taller and thinner because it is, the aspect ratio is just a little bit off. You can tell by this, it's just a little bit. But they're now the same size. So now we can blend these two as long as they're the same size. We wouldn't be able to if we didn't do the resize part of it. Then we want to blend it. So basically we're going to have what's called an alpha image and a beta image. We're going to put those together. Alpha, 0.5, autocomplete knew what I was thinking. Beta, this image, we're going to do 1 minus alpha. So this should be about 50-50. So 50% blend of each image. We're going to take the images, merge them together, and they should be about 50-50. So they'll be the same. And yeah, blended, let's see, we're just going to make one blended image. So we'll call this blended image. And look at that. That's awesome. Autocomplete. Auto-completed the function for me. Look how much faster and productive that is. Anyway, so we add weighted is the term that we use. So our blended image is, we'll take this image here and we'll say image 1, which is the woman smiling. We're going to apply the alpha transformation to that. So we're going to take that and just basically take half the image. So half the image is going to be her. Then we're going to pass in image 2, which is going to be beta, which is going to be 1 minus alpha. So they'll both be 0.5 at that point. So 1, take away 0.5 is 0.5. So they're both 0.5. They're both even, 50-50 either way. And that's our blended image. So let's do blended. This one's really cool. This is another artsy one. Like you could make some art with this, I think. Blending. And we've got our 3 images. And there we go. We have smashed 2 images into one. And it's 50% for each one, which we can change that a little bit. We can slide it kind of back and forth. We can say 70-30, 90-10, whatever we want by adjusting those alpha and beta values. So sometimes I've seen it where people just put in 0.5 on both of them. They don't even pull out the values and mess with those. But that's something you can do. And I'm doing a quick tech check really quick here and a reminder. I'm always streaming on Twitch. I'm sometimes streaming on other stuff. Like today, I'm streaming on other stuff. It's cool. And it looks like my LinkedIn feed just died at some point. My apologies if you were on the LinkedIn one. But that's the way it goes. We're always on Twitch. So this is image blending. Pretty cool, right? Blend an image here, blend an image there. Let's quit out of there and let's change those profiles like I said. Let's change this to 0.1. What happens when we change that value to 0.1? It is mostly image 2. It is 90% of image 2 and 10% of image 1 with this blending, which of course can go the opposite direction. Let's see what the exact opposite of that is. Now it's 90% of image 1 and 10% of image 2. You can see a very faint thing. So that's where this would be kind of cool. What I think this would be great for, like an immediate use case for this, would be watermarks. So you just take a watermark and blend it in with the image. make it 10% or whatever, 20%. So you just have this light little, jeremymorgan.com across the bottom. That's a good use case for this, like a good watermarking tool. Because a good watermark isn't going to be just, a logo or writing slapped over the top of something, especially if you put the watermark over the image. Like, let's say I'm a photographer and I want to give folks these images so that they can look at it and see what they look like, but they got to pay to get the unwatermarked version. You wouldn't want to just slap your logo over top of this woman's face or this man's face. You would want to lightly blend it in. So that's one of the things that one of the use cases I could see for this blending right away. So if you're generating cool art images with AI or drawing them with a tablet like I'm trying to do lately, and you want to, blend over a watermark or something, you could use OpenCV to do it. You could do it automated. You could take, let's say you have 500 images of your family vacation. You want to watermark all of them. This is how you would do it. You could automate this, and you could make Python go through every single image in the folder. And like we go here, result PNG. Looks like we haven't written to result for a while, have we? Oh, no, we haven't. Let's do that really quick. Let's write our blended image. But you could iterate through the whole, like just have it go through every JPEG in a folder and put watermarks on all of them. And you would have your cool watermarked image. So we're going to dig into this more in future streams. So next week, I'm going to be doing the same stream, doing the same kind of stuff. So next week, maybe we'll dig in a little bit more into JPEGs and how they work. JPEGs and PNGs. Next, let's see what I have on my notes next. So we blended that. And yeah, we can do various precision on this. I have that in my notes. Make sure to show the different precision you can do. See that? 60/40. Pretty cool. So, if anyone has any questions, feel free to drop them in the chat. Looks like we have quite a few people on here today, which is great. If you have questions, send it my way. Next, I have resize the image, which we did up here, but we're going to do it again a little differently. Resizing the image is super important. It's something you're going to do all the time. In fact, that is one of the more processor-intensive, time-intensive things that you'll do with computer vision. So let's say if you're analyzing 500,000 images for a certain thing, you're looking for something in that image, you have to do some pre-processing. And the pre-processing can take, like I said, a lot of time and power, because part of it is you're resizing all those images to the same size, especially if you're using models. If you start to pass things into other models, those models are going to expect every image to be the same size. So you got to resize them all to the same size. You got to make them all grayscale. That can take some horsepower. So there's something to keep in mind, that especially if you're comparing images, they have to be the same size when you're comparing them. Otherwise, you just have a bunch of math going on that doesn't need to go on, and you're introducing complexity where it doesn't need to be. So we're not going to write that anymore. We are going to put this into a web app. I'm going to build a web app, like maybe do some Python functions. I love Python functions. If you're a Python programmer, you definitely need to do like lambdas and stuff. They're really cool. So maybe I'll build a few lambdas that resize images, stuff like that. Grayscale them. So here we can do a new size. We did this image resize here, but we'll say we want to resize this image here. We'll start with image 1. Okay, we'll say Python resize py. We've got our image 1, so we're popping it up, we're showing it, we're happy. What you want to do is create a new image size. And as you can see, autocomplete worked there. New image size of 200 by 200. Let's resize it bigger than that. That's just too small. Let's say 900 by 900. We want our new image size to be 900 by 900. And that looks like garbage. I'm not sure why that isn't working the way it should. Image size 900 by 900. Oh, yeah, we actually have to resize. We still have to use the CV2 resize. I don't know. So we'll say resized image. There we go. Perfect. CV2, do inter area for this one. Okay, so resized image. I don't know what I was thinking there for a minute. I did this new image size, put in the values, and then tried to display that. So we still have to use CV2 resize. But in CV2 resize, before we put in this tuple of 2 values, image shape, and that was like some number. I don't know exactly which number, 300 by 200 or whatever. Instead of that, we're defining it up here because we want to be able to tweak it and kind of tune it. And so we bring it into its own variable called new image size. We're going to resize this 900 by 900. Interpolation, we don't really need to get into that, but inner area is a pretty good one. Let's resize this. There we go. 900 by 900 image. Now, why is that a problem? Well, this person would probably be angry with me if I were to resize her headshot like this, because this is way out of aspect. It looks funny. It looks strange. In fact, we can do a quick comparison. Image 1, image 2. Here's the original image. Here's the stretched out, strange image. So how can we get around that? Well, that's the aspect ratio. The aspect ratio is one of the things that we need to figure out. So we did this image shape 1. Let's write that out really quick so we can see why is my copy and paste not working. Pebcac error, I'm sure. Let's just print out these 2 values. 300 and 900. So we took 300 and changed it to 900. Now what about the other value here? 3 and 3. Because I did not put in the proper. Now we went to 450 to 900. Now what do you notice about this? 3 times 3, 300. 3 times is 900. 450 times 2 makes 900. So that's where we've screwed up. We have one that's scaling by 3 times, one that's scaling by 2. So we just need to figure out what that aspect ratio is, which of course we can do by saying aspect ratio. Look at that. We can find our aspect ratio from these. We can do, we can actually do height and width like this. And my autocomplete even knew what I was going to do because clearly I use tab 9 a lot. And it's already figured out what I'm going to do here, which is we're taking the height and width out of that shape object. When you do this :2, that enables you to slice it and grab height and width. So we can say height and width of this, our aspect ratio is now going to be width divided by height. Very cool. So our new image size, if we want it to be 900 wide, that's fine. But then we need to do by aspect ratio. Now the new image size, if we want it to be 900 wide, that's fine. It's going to take the other one and attempt to move it to 900, but it's going to divide it by that aspect ratio so that it keeps the size looking, so it keeps the aspect ratio that we had before. See that? Isn't that much better? The quality of the image obviously isn't better because we've taken the quality of image here where it was at 300 and we've just multiplied both of them 3 times. So that's how you do the aspect ratio. That's one of the things that's very important for certain types of images, especially if you're doing image analysis. You want to keep those aspect ratios proper. Like if we're doing face detection, we don't want to take our face, smear it out this way or smear it up this way because you're not going to be able to read that. And I see something in chat here. Do I have another spam message in chat? It kind of looked like it. But that's fine. Just delete that. Cool. So here are our images. So we've taken that aspect ratio and say the new image size, we wanted it to be 900 tall. I kept saying 900 wide, 900 tall. And then we'll figure out that aspect ratio here. And of course, there are smaller, or I should say more concise ways to code this out, but this is kind of what we're doing here. Get the image dimensions, get the aspect ratio of the image. I'm not sure why I'd do 2 of these. We don't need 2 of these. There we go. And so what can we do if we have 2 different images? Like both of these look like the aspect ratio is pretty close. Let's do the same exact thing with image 2. With 2, image 2. Show 2, 2. This one is also aspect ratio 2. And this is kind of hokey, but this is what we're doing right now. So I'm going to take both of these images and resize them according to their aspect ratio. Let's see, image 2, this one's going to be image 3, this one's going to be image 4. So image 2, resized image 2. Let's look at both of ours. I'm not sure how I ended up in the REPL there, but that's fine. So we're going to say Python resize.py. Now I've got a bunch of resized images here. It looks like I messed up my code because we've got 2 images of her and only 1 of him. Image 2, resized image 2. Ah, that's what I did wrong. Okay, so now we have big images for these 2. Are they the exact same size? That's the question. So let's find out. I don't think they're going to be exactly the same size. So remember where we went up here and said height, width, etc. We're going to do the same thing, except we're going to do it with our resized images. Say print resized image 1. Yeah, I didn't think I'd be able to tuple here. Let's see. Image 1 height, image 1 width, and code complete. Knew exactly what I was going to do with that. Image 2, okay, perfect. So resized image 1 is going to be image 1 height, 1 height times image 1 width. Perfect. Now we're going to print out our resized dimensions and see what those look like. Only concatenate string, not int to string. Sorry, Python. I forgot. Let's convert all of those things to strings. All right, cool. We've got our images resized. We quit. Resized image is a little bit different. That is hard to read because of me accepting that auto-completed code. So now they're 900 wide. They're different heights. I'm going to take a different one. I'm going to say we're going to go pexels.com. I'll bring this over here so you can see it. This is where I'm getting these images from. Pexels.com. Let's find one with like a wider image. Or I suppose we could make it wider if we needed to. We'll take this gentleman on a bicycle. And this one's going to be bike JPEG. And actually, I forgot, I can change the size. See, that's 2000 by 3315. I do not want that. I would like a small one. And we'll make that one bike. Replace. I'm going to keep that one for a future one, but I'm trying to find one with more of a horizontal. There we go. This one's more horizontal. So we're going to say kids.jpg for that one. So what problem we're going to have here? Let's say we're going to do some analysis, right? Because that's what OpenCV is, obviously. We're going to do some analysis on this, so we need to resize that image like we resize all the other ones. Let's just go ahead and do that really quick. We're going to say kids. Which is image 3. And let's say we're going to do analysis on just one of these, actually. I don't want to muddle it up with 3 images. So image 2 is now going to be kids.jpg. So we run this, and we can see that we've resized both of these images. This is the original one of the kids. This is the one of her. The kids one isn't really resized that much, so I will download that again. Except we're going to do a small one. Download that. Kids. Replace. We'll save it. Drag this back over here. And run it again. There we go. So these are different aspect ratios, obviously. Different height and width. But they become sort of the same height and width. Or I mean the same width. Not the same height and width. Which is our problem. We have the same width. They're both 900. But this one's 900 by something, where this one's square. So we need to add padding around that. That's how we solve for this problem. If we're going to analyze these images and we need them both to be the same size, then we need to add some padding. So that's what we're going to do. So 224 is very common size for loading images into a model. So we're going to resize these. And we're actually going to make them smaller. We made them bigger before, we made them smaller. So now they're 224 wide. But we want these to be 224 by 224. How can we do that? That's a problem. Because we're using we want to maintain this aspect ratio. Now, of course, we could just do it the easy way, right? We could say new image size. You know, this model I'm using requires 244 by 244. So we'll do it the easy way, and we'll say, okay, make both those images 244 by 244. And there's the problem that we have. Aspect ratio's off on both of them, right? They both look a little funny trying to meld into that 244 by 244. And they are 244. We can look here and validate it. They are 244 by 244. However, they are both, the aspect ratio is off on both of them. They're both kind of goofy. So how do we fix that? Well, I still want to maintain that aspect ratio. So I'm going to bring this back in. We still want to maintain that. We don't want to goof around with it a little bit. So I'm going to copy in some code here so you don't have to watch me type it. We're going to use a method called makeBorder. So we'll take new image size. Copy that into here. And resized image. We're going to move this up here. Whoops. And then I'll explain it. So we'll take this. We'll do that with this first one. So we do resize it here. We take new image size, 244 by the aspect ratio, and move it. And then we say, if the new image size 1 is greater than 2, or is less than 224, then we need to add some padding to the other side. So we do pad top, which is 224 minus whatever the difference is. And same thing with the padding on the bottom. Padding on the bottom, we just say 224 minus whatever that size is, minus pad on top. And then we have the padding for the top and bottom, or side to side, whichever way it needs to be for that. And so we add pad top, pad bottom, and we do that with CV2 make border. So make border is pretty cool. Make border is a way to obviously make a border around a screen. It's exactly what it sounds like. But you just take the pad values and say, okay, I want 20 pixels around the entire image, or I want 20 pixels on top and bottom, 50 pixels on the side. It's really cool. So we have our padding in top and bottom here. CV2 border constant, and then value 0, 0, 0. So now let's see what that image looks like. So we're doing this with resized image. That's that first image. Let's look and see what our 224 looks like. And it looks exactly the same. So let me make sure I am doing this right. CV2, resized image. Yeah, image 2, resized image. It should be able to pass pad top, pad bottom. Let me see if I'm doing this right. New image size divided by 2. So we're trying to make this 224. Yeah, this doesn't, I don't actually see the padding on this one. It looks like it is 105, 240 by 350. So that's not quite correct. So we'll mess with that a little bit. If the new size is, so we're doing 224 int. Yeah, it should be the length. Let me try the zeros here. And it's still not doing it. Make border equals. I probably shouldn't have copied this in. This worked in the past. Let's see. Sized image 275. I'm going to take that original image here, which is IMG, and try that. Still not quite what I want. So let me look at my notes here. Resized image. Yeah, we do resize it. New image size, 224 by whatever. Interpolation, CV area. If new size, 1, 1, 1. And resized image is pass in resized image. Pad top, pad bottom, border constant. This one does not appear to be 224 by 224. In fact, we have it right here. It's 1366 by 244. Less than 224. I just want to print this out to see if we're doing this or not. Nope, we're not. Which is why I was thinking of looking for 0. Let's see if when we do it to 0, I don't think it's going to hit it either. And it does not. New image size. Let's try this. Let's try resized. That's what I thought. That's not going to work. So our new image size, 244, then 245 by the aspect ratio. So we're going to do what programmers do, right? We're going to print this out. Print. See what value we're getting here. 366. And that one fails. Less than 224. Yep, there's no way. Assertion failed. Yep, there's no way it can do that. So we're going to print new size 0. New size 0 is 244. That's what I messed up with. Should be 224. I said that multiple times and still somehow messed that up. But it's still not doing what I need it to do. Because I need to change these back to 0. Still not doing what I need it to do. 224, 224. Okay. And I'm going to Google this to see what I'm doing wrong. Now, I've done this one several times, so I'm not really sure why it's screwing up, but image, shape 2, length append. Make border. Please log in. Okay. Check something really quick here and see what I can figure out. Why is this thing being goofy? Here, resize. Here's a way using NumPy, which I've NumPy slicing to copy the input image onto a new image of the desired output size and a given offset. That might actually be a better way to do this, is to put a border on it. But we're going to just step through the code that we have and try to figure this out. So, new image size is 224 here because we're resizing it 224 by 224. And we press new image size 1. What does that end up being? 336. So if it's greater than 224, we need to add padding to it. So 224 minus new image size, that isn't going to work. New size 224, int 224 by aspect ratio. Aspect ratios width by height. I think you need to check 1, not 0. Yeah. Thank you, Imposter Engineer, new chatter. I think if 1 is greater than 224, it's still not padding it. And actually, we're not going to show these ones because we're just adding confusion. Okay. So if it's greater than 224, it needs to be, so these ones, the long image, or the images, the aspect ratio. Hello, Psychovisuals. Have a great day yourself, sir. I will be sending you memes later, depending on how busy I am today. Let's see. Okay, so we got image size here. Let's just print out the image, the first image here. We are resizing it 224 in this direction, but not in this direction. This is the size that we need to, or this is the one that we need to focus on. We need to focus on that long edge for sure. So maybe I will change this a little bit. We'll keep our old version. We'll just switch these two around. 224. 224. Oop. New image size 2 is not defined. Oh, yeah. That's fine. We're not even using it. Okay, and we're maintaining that aspect ratio still. Don't want to do that. Or aspect ratio. Yeah, I'm not sure why new image size 2 print size 2 0 size 2 1. Let's see what those values are. 224 by 175. Take these other ones out here, resized. Yep. This one. All right, let's see what our new image size is supposed to be. Sorry, Python. 224 by 175. So when we resize this image, we do resized image, that should be 224 by 175, which is not correct. $224, 5. Oh, and I need to start another terminal again. There we go. Python resize.py. 224 by 175 is what this one is. So if we look here, it's resizing it. Not 224. This one's resizing it 224 by 335. So I'm going to put this in here. Come on. Copy plus this. We'll make it a string. Okay, I don't want to do find. And we're going to put new image size. I hope I can get this figured out in 10 minutes. Because I need to end the stream in 10 minutes. The pressure's on. New image size 224, 175. So the 175 is definitely less than that. So new image size. And we're doing new image size 2. So let's look at this again. New image size should be 224 by 175. So that 175 is less than 224. Resize it to... So why on earth does it not work? So we're going to say new image size should be, new image size 0, new image size 1. Okay, so it should be, and it's going to tell us it should be 224 by 175. Then we're going to do resized image with the new image size. Let's just copy this really quick. I don't know why the right click suddenly doesn't work. Print. Resized image is, and we'll see what that resized image size ends up being after we resize it. We're going to take image, resized image, holy moly, we're printing stuff out here. New image size should be 224, 5. Which is, hello, Fibu, I believe, hope I'm pronouncing that right. Thank you for joining the stream. We are having fun. Oops, and I just closed my chat window. Shouldn't do that. All right, so new image size, resizing should be, so yeah, it should be new image size 1 is less than 224. This should be displaying that. Should say less than 224, because new image size, as we know, we're printing it out up here. New image size 1 is 175. So why that's not parsing it, I don't know. New image size 1. Plus string actually, let's let that autocomplete work. It's printing out exactly what we had before. 4x175. So 175 is definitely less than 224. New image size is 175, so I'm not really sure why. Let's try image 2. Okay. So new image size, new image size. I will figure this out one way or another. Oh, the new image size is 336. So it's greater than that. We need to resize that. This is why, because the images are elongated. That is the issue that we're having here. So in order to get these down where we want, I think we're going to have to do something a little different. And I thought I tried this before, but we're going to swap these. Four. Now it's longer that way. But we need to maintain, we basically need to enforce this to go to 224 by 224 and pad it if it's less. Now with this one, new image size should have been less than, oh, new image size is 224. New image size should be 336 by 224. We don't want it to be 336. So what we need to do is enforce that image size. We need to enforce the 224 in here. I'm going to check my notes to see what I missed here. Height and width. Shape 2. We're just doing a regular IM read. Our aspect ratio. Width by height, width by height. New size. Let's see what that aspect ratio is. 0.6666. So yeah, it should be dividing that. That's interesting. So aspect ratio is 0.666. So there we go. That's what I was doing wrong. It's dividing when I should be multiplying. Comma, 224, comma. Oh yeah, I gotta create another terminal. I've only done that about 10 times today. UX, grep, Python, kill-9, 46469. All right. Python resize.py. Oh, now it doesn't work. So new image size should be 224 by 149. Image size 149. 149 is less than 224. So I've got a pretty serious logic error in here that I'm just not sure about. And this is obviously a me error. This isn't an OpenCV error. This is a me error, a programming error. Problem exists between keyboard and chair. So new image size, string new image size. Okay, so it is at least figuring that part out. Where is our border? There's our border. But it's still not right. Now we're at 224 and 224, but that aspect ratio is not correct. No, I've usually done the divide by aspect ratio. That's why I'm a little confused. And maybe I'm really confused. Maybe there is a border here and I'm just not seeing it with my eyes. So one thing we can do is write it and open it up in GIMP. So we're going to go down here to CV2. I am right. Let's say resized image 2. CV2 dot I am right. There we go. Resized image. Quit. And we have resized image. Nope, no border on it. So it wasn't just my imagination. It's actually not working. It's actually legitimately not working, this border part. So I'm going to have to fix it during another stream, this particular thing. Darn it. So yeah, this is a little weird, but I will show you something cool that I wanted to show today. So I got really hung up on this for comparison thing. Just step through it again really, really quick. Opening up Smile. One thing we'll do is we'll get rid of all of the second ones so we can just focus on the one. Just comment out a bunch of stuff. Resized image. That's our resized image there. Resize image. 2. We don't care about that one. Resized image here. Resizing image, the original image, to the new image size. Interpolation doesn't have anything to do with it, so we're resizing it to this new image size. And then saying resized image is X. And so it's resizing this 224 wide, but we need it to be 224 high. And we can do that by switching these, switching the position of these. There we go. Now we're 224 high, but not 224 wide. Okay. Size 224. Maybe we should do a not equal to that. And this is exactly how I've done it before. But I'm going to have to look it up. I think you need to check my chat. I didn't even realize my chat was not working. First time chat, Imposter Engineer. I think you need to check 1, not 0, because 0 is set to 224 by you. Yes. Wait, padding is for less than. Yep. I like to end my streams on a high note, but I think I'm going to end my stream with brokenness, because I am going to need to jump off of here pretty quick. Indeed. So I will have to come back to this. I will do another stream. We will come back to this. One of the things that I wanted to show was some object detection, but we're going to have to do that at another time because I do need to jump off of here. But I want to thank everybody for coming to the stream. We actually did do a lot of cool stuff that succeeded. This padding and resizing thing did not. However, I'm going to solve this, and we'll do it on our next stream. And I'm going to put an article on jeremymorgan.com that covers all of this stuff that we did. So, and we'll put it on GitHub. That way you don't have to try to scroll back through this video. Even though I do notice that I get a lot of folks that watch my videos after the stream. I don't want you to have to go through the stream and stop and pause for the code and things like that. So I'll put it up on GitHub and jeremymorgan.com. Again, thank you all for coming to my stream. Twitch folks, we are going to raid a cool stream. We're going to raid David Neal's stream where he's writing some cool games in JavaScript. So stick around for that. And again, thank you everybody for coming to my stream. I will see you next week or sooner. But I do this every week. So, every week, twitch.tv/JeremyMorgan. I don't do it every week on LinkedIn or YouTube or any of those things. So make sure to come here to see stuff every week. We're going to do more computer vision stuff. We're going to do cooler computer vision stuff here soon. But again, thank you all for coming. And yeah, see you next week or sooner. Follow me.